Hi, welcome to RVSP series lectures. So now in this video, I would like to discuss about different methods of defining conditional event. So in the previous video, we discussed about what is conditional distribution function and what is conditional density function. Now in this video, we will discuss about how to define a conditional event. So generally, to define conditional event, if suppose I have one event B. So in the previous lecture, I have taken event B as already given event, and based on that only we defined distribution function of x of x by b, like fx of x by b, a conditional distribution function, or fx of x by b, a conditional density function. The two we have defined with respect to one conditional event. Now, what are different methods to define event B as a conditional event? As a conditional event. So generally we have two methods. In the first method, event B is defined as in terms of the random variable x, the random variable x. And in the second method, event B is depend on some random variable other than x. So these are the two methods of defining event B. Start with the first event. So method 1, I'm going to take method 1. So here event B is in terms of x1, a random variable x. So that's why I'm taking an event A. Let A as an event which is given as x less than or equal to x. Okay. Next, I'm taking event B as x less than or equal to b. So here b is a constant which lies between minus infinity to plus infinity. So based on the two events A and B, I'm going to define conditional distribution function. So fx of x by b is equal to fx of, instead of taking A, I'm taking fx of x simply. So fx of x by x less than or equal to b. So you can express this as x less than or equal to x by x less than or equal to b. So there is no problem in this expression. So probability of A by B form you can use. So probability of A intersection B and probability of B. So I am taking this expression as like this: A intersection B divided by probability of x less than or equal to B. Okay. And this term does not equal to 0. This term, the denominator term, should not be equal to 0. And this is valid only for all probability of x less than or equal to b is not equal to 0. Okay, so from this expression, for different cases, I'm going to take the equation for distribution function, conditional distribution function. So this is the expression, final expression, what we have, fx of x by b. So here I'm taking case 1. So in this case 1, if x is greater than or equal to b, so what happens? So here in this expression, x less than or equal to x intersection x less than or is equal to b divided by probability of x less than or equal to b. So now what I am taking, this x value is greater than b. So then what happens if I am taking intersection of the two? Then this event x less than or equal to b is subset of this one. So that means, so then x less than or equal to b is subset of x less than or equal to x. So then probability of x less than or equal to x intersection x less than or equal to b is equal to, by default what you are going to get, x less than or equal to b only, because this is the subset of this one. So automatically you are going to get x less than or equal to b as an output. So therefore fx of x by b is equal to probability of x less than or equal to b divided by probability of x less than or equal to b, and the two gets cancelled and the function value is 1. Okay, and this is case 1. So now I am taking case 2, other condition. So now I am taking, if x is less than b, then if x is less than b, so what happens, fx of x by b is equal to, the condition is x less than or equal to x. This is the resultant of the intersection, and probability of x less than or equal to b. So you can simply write this as fx of x divided by fx of b. Okay, so this is the case 2. So then finally the conditional distribution function is, simply I can write fx of x is x less than or equal to b is equal to fx of x divided by fx of b for x less than b, 1 for x greater than or equal to b. So this is the expression, and here fx of b should not be equal to 0. Okay, and based on this we can define density function as the conditional density function is fx of x by x less than or equal to b. I'm going to use the properties relating density function and distribution function. So the distribution function is written as fx of x, the density function, and fx of b is written as minus infinity to b fx of x dx based on the property relation between the two, and for x greater than b. And for other conditions this is 1 and it will become 0. So for x greater than or equal to 0. Okay, so this is conditional density function, and the conditional event has non-zero probability. So generally if that is 0 less than fx of b less than or equal to 1, so in that situation you can write fx of x by x less than or equal to b is greater than or equal to fx of x, and fx of x by x less than or equal to b is fx of x. So the conditional density functions are greater than the normal density functions. So this is about method 1. Now let us see one more case. So if b is taken as an event which is taken as a less than x less than or equal to b. So now it is taking, the event b is taken in between two constants a and b, real values. So now for this case, if b is taken like this, then what is the distribution function and what is the density function we are going to get for different cases? So now fx of x by b, where you can take this as fx of x by a less than x less than or equal to b, and you can take this as probability of x less than or equal to x, a less than x less than or equal to b, and you can follow a probability of a by b form. Then fx of x by b is equal to probability of x less than or equal to x intersection of a less than x less than or equal to b divided by probability of a less than x less than or equal to b. Okay, and the condition is this denominator should not be equal to 0. You should remember this one. And now we need to take different cases to simplify this expression to get the final value, final equation for this conditional distribution function for the given event b. So I'm taking case 1 here. So if x is less than a, so if you observe the events x less than or equal to x and a less than x less than or equal to b, so here this event is starting from a to b and this is up to x. Now what I am taking, x is less than a, that is this is less than a means this is one event and this is one event, and there is no any common elements between the two events. So you can take these two events as mutually exclusive, and the probability of the mutually exclusive events is always 0. So then fx of x by b is considered to be 0 only. And now I am taking the other case, case 2. So if a is less than or equal to x less than b, now I am taking that x is greater than or equal to a and less than b, that is a condition. So what happens to the intersection value? So now here x less than or equal to x intersection a less than x less than or equal to b. So if you observe the given condition a less than or equal to x less than b, so what happens here? This x value is greater than or equal to a but less than b. So if you take the two events x less than or equal to x and a less than or equal to b, then what is the common element between the two? X is taken up to b but not b. So you can take this as probability of the common element is should be, so you can take a, so a less than x less than or equal to x only, less than or equal to x. So because you are not taking x is equal to b, x is always small x is less than b only, so in that interval only the common element is going to be like. Okay, so therefore you can take this as fx of x by b is equal to probability of a less than x less than or equal to x divided by probability of a less than x less than or equal to b. So as per the properties of distribution function, if I have probability of x1 less than x less than or equal to x2, then you can take this as fx of x2 minus fx of x1. Now I am going to use this form, then here it is going to be probability of, this is going to be fx of x minus fx of a divided by fx of b minus fx of a. So this is the expression for this condition. Okay, now take another condition, case 3. So if x is greater than or equal to b, so simply this is very simple condition. If you take x greater than or equal to b, and in this x less than or equal to x intersection a less than x less than or equal to b, so what you are taking, x is greater than or equal to b, so then automatically this event is going to be subset of this x less than or equal to x event. So automatically the common element is going to be a less than or equal to x less than or equal to b. So therefore fx of x by b is equal to probability of a less than x less than or equal to b, and the denominator is also the same, a less than x less than or equal to b, and there are common terms on the in the numerator and denominator, so you can get the value is 1 for x greater than or equal to b. So finally, based on this event b, which is taken, the probability distribution function fx of x divided by a less than x less than or equal to b is equal to 0 when x is less than a, and fx of x minus fx of a divided by fx of b minus fx of a. So when you take the case a less than or equal to x less than b, and the value is 1 when x is greater than or equal to b. So this is the final expression for distribution function for the given conditional event b, and the corresponding density function is taken as, so since here it is 0 and you can get 0 here for x less than a, and the term is going to be taken as fx of a divided by integral a to b fx of x dx for a less than or equal to x less than b. The value is here 0 for x greater than or equal to b. So this is the expression for the conditional density function. Okay, so this is about defining the conditional event in the method 1, where the event b is expressed in terms of random variable x, and we have taken other method where the conditional event b is dependent on another random variable y instead of on x. So we'll discuss later the method 2. Thank you.